So our topic at hand today is going to be automatic transmission operation and testing. And boy, that's a mouthful. And I tend to write um, really long titles. They're more descriptive than anything, but that's kind of the gist of what we're going to talk about. How do they work? Um, electrically wise, anyways. Not really going to get into the mechanical nonsense a little bit, maybe a little bit towards the end, but mostly the stuff that you can test with a scan tool and a scope and all that good stuff, and how we might go and diagnose some of these problems out there. So let's talk about, first off, some components. So we'll go through gear selection, and we'll start with the old tried and true. And I'll tell you what, even brand spanking new cars use this way. Some other vehicles don't now, but some just think, hey, it works perfectly fine. Why mess with it? And I tend to agree. So this is the old hardwired cable to a switch. So you got a little, in this case, this is on a Subaru, but it's got this little kind of rotary switch there. It attaches to this mechanical part. So the cable actually attaches right there with a little clip. And this is mechanically attached inside the transmission to change, the valve body to change where the fluid goes. But this is your electrical component here. And it's like I said, it's a simple rotary type switch. You want to test for continuity between pins as you manually move it along. Proper alignment is also key on these. And I know there's some vehicles, like I hear on some Chevys, if that's not properly aligned or it gets out of alignment, there's some functional tests you won't be able to do. And then the other thing is you might not be able to start the vehicle if it's slightly off, because it'll think it's not in park or not in neutral, thinks it's in reverse or something like that. And then say, well, I can't start it. So now the car's a no start. And the culprit was just this switch got a little skewed on its axis there. You can see how it got longer, some oblong holes there. So there's actually a pin that you would line this up on the side of the transmission, and I'm pretty sure other manufacturers do the same thing. Just to align it and make it so it's perfectly where it needs to be, so it's sending the right signal to the TCM. Some modern switches, however, are internal inside. You can't even get to them unless you drop the pan or whatever. So just be aware there's multitude of different ways that those can be found, but make sure that they are lined up right. And it is, like I said, a simple switch. So we just have this one goes to the exterior lights because that's for the reverse lights. And then we have the starting charging system. We go from park and neutral, allows it to start, right? So if the switch is mechanically in reverse, it's not going to send that signal to the starting charging system, like I said. And then we also have a kind of a duplicate over here that sends the different signals off to the TCM in order for it to know what gear it's in, right? Then some vehicles also have a sport mode, right? So it's just a little micro switch that kind of goes off to the side, and then you could shift it up and down, and that'll tell it, okay, shift up, shift down, mechanically there. Simple switches for plus and minus. You're going to test for continuity between pins. Nothing fancy here, just an electrical connection. Alternatively, steering wheel paddles and switches might be used, and then that's where it might get into maybe data network, LIN bus, that sort of thing. It could be micro switches, depending on the technology that the manufacturer decided to use, but I'd say more often than not on a newer car, it's probably going to be a LIN type situation there. Then we have this. And when this first came out, I thought this was like the silliest idea that I'd ever seen. And a lot of people over the years have agreed with me. So let's put a bunch of big knobs together that do a bunch of different things. So we're going to have the Prindle knob, and then we have the volume knob, and then we have the HVAC knob, and they're all kind of right next to each other. And if I'm trying to pay attention on the road or trying to pay attention while I'm backing up and then going in the drive or whatever, I just turn the radio up instead, right? It's used in FCA vehicles. Other vehicles use it too, but I think FCA was probably the first culprit for this. It is a digital rotary encoder. All communication is over the network, and you would use a scan tool to diagnose this. So here's a kind of the wiring diagram looking at that. So this is the shift module here, and you see how it goes kind of over data lines over to the data bus for the electronic shifter. So you can just kind of see how that goes. So that would be a data bus signal, a CAN bus. Notice how it's using CAN bus. So if you know how to test CAN bus or what CAN bus looks like on a scope, that would be the way to test it. And you can also, of course, verify with the scan data to see, okay, I put it in reverse. Does the data say that it's in reverse? and then you can just kind of figure it out from there. Next one. So we've progressed back to button gear shifts. If you can think way back, some vehicles used to have button gear shifts. And then that went away, and now, hey, guess what? It came back. So I've seen it in GM vehicles for sure. Other vehicles I've seen it in. Once again, this is just a module, so all communication is over the network, and you use the scan tool to diag. And once again, it's a little less dangerous than the knob, but still a little iffy having buttons near the other buttons, right? But I guess if they want to save space or whatever, reverse, neutral, and drive. Some of them you have to pull up in order to make it happen. Interesting. And then the button gear shift is its own control module, like we can see here. And then it just kind of goes off over the network. You got power, you got computer data. There's electronics in here, some sort of chip type situation, and it's just going to send data signals over the network. So once again, digital. And then we're back to 3 on the tree almost as well. So I rented a brand new Acadia a couple months ago, and I was like, what in the world? How in the world do I shift this car? So they keep making it, I don't know, less intuitive to shift the vehicle. And it's right there. I mean, is it my wipers? No, all the wipers are on the other stock now. So you would turn on your wipers and put it in reverse. I don't know. It seemed kind of silly to me. But once again, see it in GM, other vehicles too. All communication is over the network once again, and you're going to use your scan tool / lab scope to diag it. So here's the gear shift control module in the steering column, right side stock. So it looks like it might actually have some micro switches inside of it, but then it just goes to a logic board and then it just goes out. So we got battery positive, 2.5 volt reference, not a 5 volt reference. So that's another thing to keep in mind if you're testing this. It's 2.5 volts, not 5. So if you're expecting 5 volts and you measure 2.5, oh, well, it's broken. It's not. This one has a 1.5 volt reference on this side, ground, couple signals, LIN bus, right? So it's probably just sending the signal over to LIN bus to the computer data. But the battery energy control module sends a bunch of the signals to it. So it's a lot different than our classic, just standard shifter that's in the car with a cable shift. There are still vehicles that use a cable shift nowadays. I have a 2025 Kia, and it has a cable shift that shifts the transmission. It's a physical shifter. I love it. Getting away from those digital ones, and maybe I'm showing my old man age now, I guess. I don't know, but change is hard, I suppose. But I guess it might make it easier to diag, but it's probably going to be prone to failure by just, the network's not working. Anyways, let's get on to the sensors, huh? So sensors, temperature sensor is important, so it knows what temperature the fluid is. So in this case, the one we looked up was the negative coefficient thermistor. As the temperature increases, the voltage decreases. You're going to test it for voltage or resistance. Sometimes it's part of the valve body, and because of that, it could be difficult to access. Sometimes you can just kind of access it from the side, but a lot of times it's going to be kind of difficult. So here's an example on a 2001 Camaro. Transmission fluid temperature is a 2-wire thermistor. As the transmission temp increases, thermistor resistance and signal voltage decrease. Cold trans voltage is sent through high resistance circuit in the PCM. Warm trans voltage is sent through a low resistance circuit in the PCM. Dual circuit improves the accuracy over all temp ranges. PCM uses the transmission fluid temperature to determine shift patterns, engage or disengage torque converter, and determine hot mode operation. And then we can see the pinouts there and what everything is on the transmission. And then sometimes the manufacturers will even include a reference chart. So for example, if I'm looking at, just 86 degrees, just barely starting to warm up, 30 degrees Celsius, should be 2013 ohms down to, it goes from 90,000 ohms at negative 40 up to 42, down to 42 ohms at 302 degrees Fahrenheit. So actually, if you look over here, it goes maximum resistance, minimum resistance, and nominal resistance. And then you get your voltage out there. Speed sensor. Most modern vehicles is going to be a Hall effect sensor. It's going to read input and or output shaft speed and or multiple shaft speeds, depending on how the transmission is set up. You're going to be able to test it for voltage, resistance, look for voltage going to it, voltage coming from it, resistance between the pins. Sometimes it's part of the valve body again, and due to that, if it is, could be difficult to access. So here's an example on a 09 Subaru Legacy. That was their 5-speed, 5-speed automatic transmission. And these were prone to failure, by the way. Not necessarily the speed sensors themselves, but the stacks would move. and the stack that it was reading, it would kind of shift if it wasn't set up right from the factory, which could happen. So you'd get weird turbine speed sensor errors or just speed sensor errors in general. Sensor 1 reads trans input shaft speed and torque converter speed. Sensor 2 measures transmission speed. And it tells you where it is, and we can also go in there and look for voltage. GM has an interesting one in a couple of their transmissions where it's actually inside, so it reads both of the input and output shaft or what have you, and then it plugs in on the valve body itself, so you do have to drop the valve body in order to access the speed sensor, replace the speed sensor, test it. I suppose there might be an external test that you can do on the speed sensor, checking the guided component test for sure. Then we also have our solenoids. So we have a couple different types of solenoids that it might use in there. So we have an on-off solenoid. It's just open and close. The computer controls the ground side. It's powered by battery power. Open and close function. Sometimes part of the valve body. Oftentimes it's going to be, you're going to have to drop the pan anyways to get to it. It can be difficult to access if it's on the top side. Some of them, they're just kind of right on the back. Makes it nice and easy. Depends on the manufacturer. And oftentimes you're going to be probing it from the actual transmission connector, not going inside it. So we'll give you an alternate location to go. So shift solenoids 1 and 2 are on-off type solenoids. They're power side switched by TCM and grounded through the trans housing. So in this case, power side. Then they give you an apply chart down here. Then it could be a pulse width modulated solenoid as well. So it's a modulated on-off operation, and it could be, so how long does it keep it open or closed? Computer controls power or ground side, depending. Open and close percentage. Sometimes it's part of the valve body, probably most of the time, not like physically part of it. You can replace it, but oftentimes you have to access the valve body to get to it. But oftentimes you can also test it, kind of at the transmission connector. So in this case, on a 14 Ford Explorer, torque converter clutch solenoid is a integral part of the solenoid body, and being so not available as a separate unit. So you'd either have to buy it together. Both power side and ground side controlled by the PCM or TCM on some vehicles. Controls common solenoid power. Uses the torque converter lockup by varying the amount of current applied to the torque converter control solenoid. When no current is applied, that is fully released. When maximum current is applied, it's fully applied. So it's the varying current to this one. And then we can test it and check the duty cycle percentage. So in this case, this is a graphing meter checking the duty cycle. And we just went from down to up. Just using a functional test. So you can use a functional test to move it up and down and then see the results on the scope. And then they kind of give you their combinations here, the different shift solenoids on, off, or what have you with that. Just, okay, so if I'm in this gear, the apply chart needs to be kind of where it is. We could also pressure test it just to check the pressure. So a bunch of different variables there. And then the commanded pressure change here, we should have actual pressure change there. So that brings us to adaptives. So as most modern transmissions learn, it will adapt. So to equalize tolerances and where an automatic transmission adaptation takes place for shift time, clutch filling pressure, torque converter lockup control, adaptation data may be stored permanently and to some extent can be diagnosed. So you can kind of see what's going on in there. Driving style adaptation as well. Shift point is modified in steps based on the information from the inputs. Control module looks at inputs such as vehicle acceleration and decel. Rate of change as well, position of the throttle pedal, lateral acceleration, gear change frequency. So based on how aggressive the driver is, it moves up the shift so the present gear is held a little longer before the next upshift. So it's going to modify it depending on how you drive the vehicle. If you drive it like a, like a little old lady, I guess you could say, it's going to shift differently than if you drive it like a race car driver. So most modern vehicles is going to be like that. And this is an example from a Camaro 2011 service fast learn adapt. So that's going to be something that you can do with the scan tool. So it's a procedure for 6-speed automatic transmission in which a series of tests are run to allow transmission control module to learn individual clutch characteristics. So as they change. Once the clutch data is learned, service fast learn adapts translates into adaptive data cells, which the TCM uses for clutch control during shifts. Scan tool provides initiation of the service fast learn adapt procedure. Procedure is to be used following transmission repair. So anytime I do any repairs on this transmission, I need to put it into fast learn. All right, so that's the nuts and bolts control system outside things. We also have in many modern transmissions, many differences from what we may be used to. Now, I was back in the day, early 2000s up to the 2010s, rebuilding transmissions I've rebuilt. I can't even remember how many. That's what we used to do. Instead of just slapping a reman in it at the dealership, you do low reverse clutch packs and all sorts of different operations with the automatic transmissions and the manual transmissions. So we would be used to like something like this, right? So it's got a torque converter and it's got a bunch of different clutch packs in there. You can see the clutch packs there, planetary gear sets. We're not going to get into the mechanical side of things, like I said, but just know any of these could fail and you may need to replace them. Most people probably nowadays, I would imagine, get it rebuilt or whatever, or send it to a specialty transmission shop. Those still do exist as well. But this is just your standard run-of-the-mill hydraulically actuated automatic transmission. They've been around for years. The technology's been, I don't know how much it's improved over the years, but when it ain't broke, don't fix it is what when it ain't broke, don't fix it. So don't, you're going to have clutch packs. You're going to have planetary gear sets, things like that might wear out. Bearings will wear out. So if you're going to rebuild it, just follow manufacturer's instructions on how to rebuild it, I guess. Another one that's kind of unique, though, and there's a couple different varieties of these out on the market, is in this case, the Volkswagen and Audi use what they call a DSG, so a dual shift gearbox. And what that does is it's like a manual transmission, but it's automatically controlled by this mechatronics unit down here. And it actually has two clutches. So if we go and we have two different input shafts. So one input shaft's attached to one clutch, and the other input shaft's attached to a different clutch. And it's a 6-speed transmission. Half of the gear sets are intertwined with one of the input shafts, half the gears are the other one. And when it shifts back and forth, it's kind of like an even odd type thing. So first gear is one shaft, second gear is the other shaft. So when it does this, it's going to use hydraulic actuators to actuate the clutch forks, and it's like a traditional clutch in there. And then you can see how this clutch has a much larger spline in it because that attaches to the outside input shaft. And then this one's smaller. So that's the inside input shaft. So we have a much larger input shaft on the outside, smaller input shaft on the inside, and they shift independently of each other. So if I need to shift first gear, it'll shift one clutch. Second gear, it's like another clutch. So it's like kind of like an automatic actuated manual transmission. So that's how Volkswagen and Audi do it. And there's certain things that need to be done with that. We'll talk through some of the tests that can be done, the special functions that can be done. Because with the oil with these, the way it's hydraulically operated, filling them can be a challenge. Checking the fill level on some of these might be a challenge. And also there's a couple bleed procedures that may be done on certain ones. I'm not sure if it's on the example that I have, but there are bleed procedures that need to be done. There's also a reservoir in there for when I come to a stop. It needs to still be able to, build up pressure in the system when I do that. So that's kind of an interesting, did a lot of research on that in the last few weeks. So there's kind of an interesting way of doing things that is like a clutch pack that they call it. So that is kind of like a manual transmission, but automatic actuated by hydraulics. So it's like a hybrid of the two. And then we have BMW's dual clutch transmission. So this dual clutch transmission works on a very similar principle to how VW and Audi did it. However, instead of using like friction clutches, or I suppose it's still a friction clutch, but like a manual transmission clutch disc that you would expect, in a manual transmission, this uses a clutch pack like a clutch pack from an automatic transmission. So it has two clutch packs in there, a smaller one and a larger one, and depending on which shaft needs to shift, it will apply hydraulic pressure to whichever clutch pack it needs. So instead of using the shift forks like Volkswagen and Audi does, it just acts like another clutch pack within the automatic transmission. However, it's a manual transmission. So a little bit different, and that's going to have some different variables too when it comes to the scan tools and stuff like that. But as we can see, it looks like there's a cable actuator there too on that. So that's kind of interesting. And then it has the mechatronics over there. And then, like I said, that's a very similar to an automatic transmission clutch pack. It would actually be on the shaft in the case where it's actually operating. But in this case, they wanted to show the clutch pack separate. So let's see how it's got multiple plates, multiple friction plates. So that means it's more like an automatic transmission clutch pack. And then CVTs. So they came into popularity late 2000s, 2010s. Nissan Murano famously used it and had spectacular failure rates on them. This is one out of a Subaru, so I was trained on these when they came out. It was 2010 model year they first came out for Subaru. What they do is it's an automatic transmission, but it has very few gear sets and very few moving parts. The parts that change gears, so to say, are these two variable pulleys. So depending on where I put these pulleys, one's going to spin faster than the other. So that can control the output shaft speed based on how fast my output shaft is actually turning. So we have the input shaft here, and depending on how fast it makes the output shaft turn, because the input shaft can turn the same speed. The very early versions of these, if you ever drove one, it's kind of disconcerting if you've never driven one before, because you'll be driving along and it's like 3,000 RPM, 3,000 RPM, 3,000 RPM, but my speedometer is going up because it never actually like shifts, right? So later on in time, manufacturers started adding like shift feel points. So it wasn't an actual shift point, but they would make the pulleys move, I guess, in a more jarring manner. So it wasn't nearly as smooth with that, but it would feel like you're shifting. Like my mother has a CVT in her 2017, and it feels like it shifts as you go, but it is a CVT. So they figured out that customers didn't like that, where it didn't shift. But I remember PDI in 2010s, and I'm like, oh, this is wild. It's just like you step on the accelerator, it never goes over 3,000 RPM, but you are cruising along. You can get up to highway speed without feeling it shift. And that's kind of the whole point. So it doesn't take that time in between gears to shift, so that, better fuel economy. They caught on with some manufacturers. Some manufacturers used them and then decided to stop using them. Some manufacturers just decided we're going to stick with traditional automatic transmission and just add speeds to it. I mean, you have 10-speed automatic transmissions out there. My Kia's got an 8-speed automatic transmission. So instead of going with the CVT, which, depending on how it was designed and built, could be failure prone. In the case of other manufacturers, they're like, hey, I'm just going to use what we've been using for years, right? So that's just another variable you got there, the CVT. So you can see we got the two different, variable pulleys there, and it's just kind of it's hydraulically actuated. And then if we look into it, it is in, we have a control valve, the valve body in there, and it's just the TCM connects to the valve body. You're probably never going to rebuild one. I know when we went to Subaru school for this, they had us rebuild one, but then as soon as we were done, they said, oh yeah, by the way, if it ever so much as leaks a drop of fluid, it's coming back to us, because they wanted to see what the problems were. I don't think that's still the case, because I'm sure they got remands at this point, but they probably still don't take them apart. They probably just throw a transmission at it no matter what it is. So diagnosing it, yeah, if it shifts poorly, just throw a transmission at it, right? So depends on what the manufacturer recommends, I suppose. But that was just kind of an interesting thing. It's like, yeah, you're gonna have us take it apart. We take the belt apart even, so they can show how it's all chain links and everything, and then put it back together. And oh, by the way, you're never gonna do that, but we'll teach you how it works. I don't know, kind of silly to me to waste that time, but whatever. Let's go live on the tool and take a look at a few different example vehicles, as we always do, so we can see a couple of different things. So I got a Volkswagen Taos here, and that has the DSG in it, dual shift gearbox. So we can take a look at a couple of different functions on this. Just going to go through and go to our transmission. This thing's been laggy today. All right, so we'll go there. And then it was there's so many transmission variants, OGC. Where did I find that? There it is, OGC. All right, so also, this is a Volkswagen. It's a 22 Volkswagen. So some of the functional tests and adaptations may require secure diagnostic requests. It doesn't come up on this one, but depending on the vehicle, the functional test or an adaptation or something like that, you may need to do the PIN code on our tools. So that's their SFD, their secured function. So I'll go to functional tests, and this is just for the simulator. So it's just saying if it's got secure functions. We're going to call it on, let's call it locked, and see if I can show you so there we go. So if you have a Volkswagen or an Audi where the secure functions are locked, you need to enter a 4-digit profile access code. That would be in your Snap-on account. So if it's already in your Snap-on account, just punch in whatever it is. I think I'm going to do a wrong one first, just so you can see. Yeah, so if it's wrong, it'll just say it's invalid. You have 5 total attempts. So plug that in, and there we go. Should let me in. There we go. Okay. And then we'll go into special functions. And then we see we have check oil level. Like I said, checking oil. Let's see. So following steps are performed in the test program. Check the transmission fluid level, and the ignition needs to be on. I want to check. I don't know how far this lets me go. Make sure shift selection levers in P, vehicle on a flat surface, lower engine noise insulation removed. So the cover underneath. And the transmission fluid needs to be 35 to 45 Celsius. And I think at that point it's going to fail because it tells it it's at 771. So it must be between 40 and 45. So let the transmission oil cool down. So it's going to give you an error in that case. So special functions, functional tests, oftentimes it's like, well, if your parameter's not met, some vehicles were better at it than others at telling you what the parameter is. And if we find some where it doesn't really tell you what the parameter is, we have been working on improving that. So you'll see that over the updates. But in this case, it's not going to let me go any further because it thinks that it is too hot. Adapt installation info. Test program for the following steps will be performed. Establish basing setting for CAN installation information. Just have the ignition on. Adaptation of the fit information is carried out after the following activities. So if you do a software update, after replacing the control module, after replacing the selector lever, and any work on the steering wheel paddles, or after another control module is replaced, like engine, ABS, or gateway. So it's going to do and run the setting. I think it just keeps going on forever in the simulator, so I'm going to give it a minute and then we'll change it back. Yeah, it looks like it. Okay. And then basic setting, I think, is very similar to the adapt installation scenario. We need to do this after software adaptation, replacing the mechatronic unit, replacing the clutch. So if you have to do a clutch, you have to do this. Event memory, transmission system, basic setting not performed. So you may have a code for it as well. So it just goes in and does it. If the entire transmission is replaced, you don't have to do it because you don't have to reset it. It's there. Put it in park, let it idle. Fluid temperature must be between 15 and 100, and it's going to be 771, so it's not going to let me do it. And test conditions are not met, so it's going to fail out. All right, so I'm just going to cancel. I'll say cancel. And not letting me cancel. Okay. Love the simulator sometimes. All right. We'll just stop communication. We'll just reload the vehicle. I just want to check and guide a component test. I haven't yet on this one. Just see if there's transmission. Yeah, no transmission on that one. Next one I want to talk about is 2019 F350. So this one has a function in here that can save you some time. If you're here at the very beginning and watch the pre-roll video, you'll know what I'm talking about, but I'm going to talk through it again because a lot of you weren't. In this one, and pretty much any 6.7, we have a test in there under special functions for transmission characterization and solenoid identification. So if I know I have a shift solenoid that's bad, I tested it. I haven't taken it apart yet, but I know I have a solenoid or something that's bad. The solenoids are individualized. Each individual solenoid is going to be a little bit different. So you need to know the information before you order it. So instead of dropping the pan and making the vehicle not be able to move or whatever, while I'm waiting for parts, I can go in here and I can pull it. I can pull the data. So if I wanted a transmission characterization, let's use to read the transmission strategy and identification from the module. Refer to vehicle workshop manual for further details. So it's going to ask you, is this the right transmission? Sure, why not? There's the strategy and ID number. Transmission ID and strategy should match the service tag on the transmission. If the tag is missing, damage, or if the strategy identification does not match, it may be necessary to remove the main control cover and obtain the identification and strategy information from the solenoid body. So multiple ways to do this. And then if we go into the bands, not supported for all transmissions, but in this case, the simulator does. I'll just pick this one. Function will provide transmission solenoid band information for individual solenoid replacement. Body strategy or identification will be required to obtain the solenoid bands. Function can be obtained from the module or the transmission tag. So if the service tag wasn't working, and then it will pull the information from there. So it'll just tell you what the range is. This is going to say configuration error for me because I'm simulating it, but it would give you all the information you would need to know, normally close, normally open, that sort of thing. So you can order the parts before you dismantle the whole thing. I think that could save you some time. We also have clear transmission adaptives, halt adaptive learning, PMI, which is for pulling a module in and out. Stop use of transmission adaptive, resume transmission adaptive, and a couple different things in there. And then lastly, I want to go with the BMW with their dual clutch transmission. This is on a 2 series. And we'll go to transmission. And that is a QW. Oh, it's just this guy right here. Functional tests, special functions. This has oil balancing, oil adjustment, fluid adjustment, gearbox adaptation, and teach in the clutch slipping point. So gearbox adaptation, let's see. I think this one gave me some stuff. Oh, I can't do it because we're 771. Teaching clutch slipping point. Try that. Oh, once again, not going to let me do it. But there are multiple service functions for that. Fluid adjustment. Read workshop procedure before doing this. And not going to let me do it because it's too hot. Activate park. Not in park. Okay. Oil adjustment and oil balancing. Oil level in the automatic gearbox can only be adjusted when the following conditions are met. So we know we're not going to meet that. But it does give you, here's what I was looking for. So why does the oil level need to be adjusted? Are there faults stored for oil level check? Have the mechatronics or converters been replaced, or parts have been replaced? No mechatronics, no converter. So it's going to balance the oil depending on what component got replaced. So you just need to tell it what you did with the transmission, and then it does it. All right, so that's oil balancing and then oil adjustment. I don't know how far this is going to let me go. Nope, not going to let me go past that too. So a couple things to look at. I don't know if I think this one might have transmission. Let me see. Yeah, transmission in this one. So on this one, we have a CAN bus test. Fluid checking procedure actually tells you how to check the fluid, which is nice. So it's going to tell you how to do it. Transmission must be cold. Start vehicle and immediately remove the transmission fill plug. If fluid drips out the plug, remove the transmission temp in between 30 and 50 or 86 to 122 Fahrenheit. Fluid level is okay. If it does not, that means the fluid level is low. And repeat steps 1 through 7. So good to know. And then fluid requirements tells you what that is too. Don't mix. And then power, ground, TCM. It's going to give you the pinouts and stuff. All the pinouts for that. And then transmission IDing the transmissions. Trans ID label tags located on the transmission case. It's just going to tell you a little bit of information. So that is automatic transmission from the electronic side. So hope you got a few tips and tricks there. Learned about some new different transmission types, dual shift gearbox and dual clutch transmissions and so on and so forth. So with that, let's talk about what we're going to talk about next week. Let me get this out of the way. Let's talk about next week. So next week, we are going to be talking about back to our OEM-specific ADAS, and we are talking about Hyundai and Kia. So look forward to that. I'm going to talk about radars and cameras and what's unique about them. They do have some unique-looking targets for some of these things, too. So if you want to join in every Tuesday night, 6 and 9 Eastern, go to snapon.com/OT if you want to register and join on Zoom. If you do join on Zoom, you get a little certificate emailed to you the next day that you can print out, display in your shop, what have you. YouTube, we can't do that because we can't really track you actually watching it. But if you are watching on YouTube, please like and subscribe. So if you scan that QR code right there, it'll bring you right to the YouTube channel, and it'll allow you to subscribe right then and there. 9 p.m. Eastern class goes live to our Facebook page. So it's facebook.com. And it is Snap-on Diagnostics Product and Training. So go look us up over there. Give us a follow or a like or what have you. If you want to see any of the other topics in this series, anywhere from intro to ADAS down to diesel emission systems and more. This is actually episode 122. I got to put episode 121 on there. It was last week's Mercedes ADAS. But anyways, anything in between, we've talked about most of the electronic components on a car. So if you need any help with scan tools and stuff like that, check it out. Once again, you can scan that QR code. It's youtube.com/Snap-on Diagnostics. Also, do we have your email address? If we do not have your email address, you may be missing out on some stuff like Tech Focus articles, SureTrack blogs, quick tips, new product releases. So if you scan that QR code, it brings you to a form. You can fill out your information, and it will you'll start receiving this valuable information. It's only a couple of months. I mean, I'm signed up on the list. I don't get them very often, so they send out my schedule sometimes. There's a new product release. There's another new product coming out pretty soon as well that you're going to start hearing about. So all that information is readily available. So you won't know if you're not on the email list. So sign up right there. All right, time for questions. So if you do have a question on Zoom, just look for the Q&A button, top or bottom of your screen. I will get to those in a minute. Also, we have some activity on YouTube. We'll talk through that. If you are on YouTube, please feel free to use the live chat function while we're live here. And let's see what we got. We got one on Zoom. Got two on Zoom. Like I said, if you do have a question on Zoom, please use the use the Q&A button. Let's see, Jay, thanks for the class. And for me, CVT has a problem. It's an automatic replacement. Yeah, I'd say you're probably not going to take them apart. If they do have a problem, like I said, you can replace it. It's probably the MO for everybody now. Thanks, Jay. And then Amber says, what if we don't get our certificate? Please email me. You could email me. It's jason.cabrinas@snapon.com. Or you do get a reminder email for the Zoom class from, I think it's Diagnostics Marketing at snapon.com. You can email that one as well. I think that one probably might be better because that goes right to the people who actually print out the certificates. Also check your spam because it might go to spam. So it's kind of an automated generated thing that we do Wednesday morning. We just go through and we perform we pull the registered data from Zoom, and then we send it off, and it gets printed out, and so on and so forth. So check your spam first. If you don't get it, please go and I would say go to the Diagnostics Marketing email address that you would get your reminder for this class when you registered. That's probably the best way. You're welcome, Amber. All right. And for Zoom, we got Nick, Mr. Nick, very late over in the UK. Always good with the saying hi, and he's here every week. I definitely appreciate it. He appreciates the free diagnostics training, so thank you for that. Jay Lee Lobo says hi, checking in, as he does every week. The Winton is checking in this week. Welcome. And Jay Lee Lobo says, very good information. As always, thank you. Let's see. All techs keep this in your toolbox. Wax crayons to use for seized bolts. Hey, that's an interesting one. Maybe you put it on that bolt head, I guess. Outstanding tutorial. Thank you guys for the input. Oh, got a couple more on Zoom. Oh, no, I just didn't hit done. Never mind. All right. So very good. Looks like we cleared the board. So thank you very much. Thank you for spending a little bit of time with me. Hopefully you learned a few more tips and things about automatic transmissions and kind of how they work. Hopefully you join me next week for ADOS on Hyundai and Kia. With that, enjoy the rest of your night. Enjoy your weekend. Have a nice night and take care.